So last time, a couple of you guys were absent, right? We had a couple of people that weren't here. Ryan, were you the only one? Okay. So two things you'll need to do here, Ryan. You'll need to open up your Microsoft Teams and find your 4th hour pre-calc tile. Click on then class notebook. And once that OneNote loads in, from the drop down, you'll select, instead of open in browser, open in desktop app, and that'll link your OneNote with the new shared folder. And then after that, in the My Notre Dame, under the links section, we'll need to register for the new Delta Math. So if you just click the registration thing, it'll open up with the code already there. You just hit register with Google and pick your school email. Dunzos. If you get stuck on stuff, holler at me, but it's pretty easy. And we've done it before, which is nice. All right. So today, we had last time we had talked about the law of sines. And we said there are 3 situations which we use the law of sines to solve a triangle. So when we have an angle-side angle situation, an angle-angle side situation, and then an SSA situation. These first 2 situations, you always get one triangle no matter what. Doesn't matter the order in which you solve the parts in that triangle. As long as you have enough stuff to do it, it doesn't matter which one you solve first or second or third. Okay? The SSA situation is a little bit more challenging. So there's 2 things we need to check. So first you need to check the size of the given angle. And all of a sudden this just pooped out on me. Why is it? Okay. Why is this being weird? Sorry, my stuff's just being real laggy. If that given angle is greater than or equal to 90 degrees, you need to check 2 things. If the side opposite the angle is shorter or equal to the other side, well, that's impossible situation because now the longest side isn't opposite the biggest angle. So 0 triangles are possible there. You can't actually do that problem. Otherwise, there's just one triangle. If the given angle is acute and the side opposite the given angle is bigger or equal to the other side, again, everything is fine. That's just one triangle. Otherwise, you can have 0, 1, or 2 triangles, and it's not entirely clear from what we had, or just the given information, which one of those 3 situations it's going to be. So the way you can tell is we're going to be interested in solving for this other angle that we haven't been given. So we set up a law of sine. So we have the given angle over the side opposite the given angle equals sine of our other angle opposite the other given side, or I'm sorry, over the other given side. So we just kind of cross multiply and then divide. And if this number, depending on the size of this number, it tells us which outcome we have. So if this number is bigger than 1, that's the impossible situation. If it's equal to 1, that's just one triangle. And if that number is less than 1, you get 2 triangles. So that's just kind of a summary of what we did on day 1. That's the 5-minute summary, because we've already talked about this once through. But it's kind of all in one place, which is nice, I guess. Today, we're going to be talking about the law of cosines. And if you remember from last time, we said that there's 2 situations we'd use the law of cosine: side angle side and side side side. And both of these we have to be a little bit careful about. So there are situations where funny stuff can kind of happen. We have to be a little bit careful. Not quite side side angle careful, but a little bit careful. So start by writing down the law of cosines. So if we have, oh no, any old triangle like this, we can write the law of cosines in 3 different ways. We can write side A squared equals side B squared plus side C squared minus 2 times side B times side C times cosine of angle A. And then 2 other versions that are basically the same thing. What does this law of cosines look like a little bit? What does this look like? What other formula does it kind of resemble? Yeah, it looks like the Pythagorean theorem with this little extra correction factor tacked on the end for it not being a right triangle. Guess what cosine of 90 is? Do you remember? 0. So when it's a right triangle, it just simply turns into the Pythagorean theorem. So that's nice. That's basically all this is just the Pythagorean theorem with that extra correction factor stuck on the end, because we don't have a right triangle necessarily. And if we do, the correction factor just kind of drops off and there's nothing to it. Okay. So let's do an example here. So solve the triangle. So I've drawn my picture. Which situation is this? We have two sides and an angle. Is this side angle side or side side angle? Side angle side. How can we tell by looking at the picture? The angle's in between the two sides, right? The two sides basically make the angle. So yes, this is side angle side. So that tells me we should be using the law of cosines. So what we're going to be solving for is the side opposite the given angle. That's the first thing we have to find with the law of cosines. So I'm just going to be using the first formula, or the first version of the formula, because I'm looking for little a. Everybody so far so good? Now notice here that we have gotten a squared by itself. What do we really want though? We want regular a by itself. So what are we going to have to do? Square root both sides. When we square root both sides of an equation, what happens? What do we make when that happens? A plus or minus. However, a is the side length of a triangle, so clearly we're just going to discard the negative sign here. So I'm never going to write the plus or minus because it's a geometry problem and there's no minus lengths in geometry. But I am going to just make mention of why I'm doing that, just to be thorough. And my suggestion to you guys would be to type it into the calculator now exactly as it looks on my sheet of paper. Don't try to turn this into a bunch of different steps. Just do it all at once. So I'm going to do square root 14 squared plus 17 squared minus 2 times 14 times 17 times cosine 34. Before I'm pressing enter, I'm going to go just check to make sure that I am in degree mode. The angles in this problem are given in degree. I'm about ready to do a sine, cosine, or tangent, so I know I need to worry about my mode. I am in degree mode, so I'm good there. So I'll just go ahead and press enter. So I get about 951 for my length for A. So now I need to find angle B and angle C. Those are the two remaining unknowns. Do you think it matters which one I'd find next? It does. It does. Why? Because once I've found A, if I'm going to find the another angle, I might end up with an SSA situation. And I want to be careful that I don't run into that ambiguous case where I end up putting together a law of sines problems that should be having two triangles. I don't want to deal with that. So I'm going to be very careful in the order I solve these things so that I can avoid having to run into that SSA situation or that ambiguous case while I'm doing an SSA situation. So it's really easy. All we need to do is find the smaller angle next. So between angle B and C, which one is the smaller angle? B. How can I tell B is the smaller angle between B and C? The side opposite B is smaller than the side opposite C. Right? 14 is smaller than 17. So I know angle B is smaller than angle C. So I'm just going to set up a law of sines. So I'm going to do sine A over A equals sine B over B. And as long as I'm doing the smaller angle next, I don't have to worry about an ambiguous case. Can't happen if I'm doing it in this order, which is lovely. That's what I'd like, right? I don't want to have to run into that inside of a normal problem. So I'll cross multiply. And then I'll divide by the 951. And then how do I get rid of the sign that's in front of the B there? What do I use to get rid of the sign there in front of the B? Yeah, sine inverse, very good. So I do like sine inverse to both sides. So the sine inverse just cancels out the sine. And then into my calculator, I'm going to type this. So second sine to get the sine inverse. I do alpha y equals to get me the fraction. And 14 times sine 34 divided by the 951. I did second and the negative sign to do the ants rather than having to type that in. And I get 5544. Everybody's good with that? And now angle C is easy because I have two of the three angles already. I can just do a little subtracty-racty. And I get 90.56. Does that feel okay so far? Again, I think easier than the worst law of sines problem. All right. This one, you should be able to tell the situation just by looking at or reading the problem. What's the three-letter situation here? Elise? We don't have any angles, so this is side, 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 right? Yep. Very good. Since none of those numbers have a degree sign after them, I know what I have is here is a side, side, side situation. Now, I have to be a little bit careful here before I even get going. Because if I give you just three side length or three measurements, can you make a triangle out of any three measurements? If I say, okay, 1, 1, and 1 million, can you make a triangle out of that has side lengths 1, 1, and 1 million? No way, right? Not possible. So before I get started, I have to check to see, is it even possible to make a triangle that has side lengths 5, 8, and 10? Does anybody remember the rule to do that? from geometry. It doesn't come up very often, so if you don't remember, that's okay. It's that the sum of the two legs has to be greater than the hypotenuse. How can I tell what the hypotenuse is? It's the biggest number. Yeah. So 5 plus 8 is bigger than 10, so this problem is possible. Everybody's okay with that? All right. Now, it's possible for me to solve for any of the three angles first. Do you suppose it matters which one I solve for first? It does. What am I hoping to avoid? I want to avoid the SSA situation where I can have 0, 1, or 2 triangles. The best way to do that is to find which angle first? The biggest. Why do I want to find the biggest angle first? If you remember back to the SSA criteria, if the given angle is not acute, we can't run into that ambiguous case. So if the angle I find is like 90 degrees or bigger, I'm good to go. I don't have to worry about which angle I do next. Everything is fine. So which of the three angles is the biggest in this case? Angle R. How can we tell? The side R is the biggest side length. Yep, exactly right. Okay. So if I rewrite my law of cosines using P, Q, and R, I have this. Now, my suggestion to you is let's not actually fill any numbers in here yet. Let's just solve this for R and keep all the letters here. And then we'll generalize a formula that we can use in this law of sines or side law of cosine situation. So that we don't have to do this algebra over and over and over again. We can just have a formula for it. Sound good to you guys? All right. So if I want to get angle R by itself, what should I do first to this equation? So it's just like undoing the order of operations. What's the first thing we do in, so undoing the order of operations is going in reverse order. So what's the last thing you do in an order of operations problem? Addition and subtraction, right? Okay. So do we have, what is being added or subtracted to my variable R? P squared and Q squared, right? So that's what we're going to start with, is just moving those to the other side. So move the P over, move the Q over. Everybody's good there? Next thing we need to undo is multiplication. Do I have anything multiplied to my variable r? Yeah. So to get rid of that multiplication, we'll be dividing. What are we going to divide both sides by? Negative 2pq. Excellent. And then how do I get rid of that cosine in front of the r? Cosine inverse to both sides. Excellent. Oops. So that's like my formula that I'm going to be using. So let's go back up to the law of cosines here real quick. And we'll write down that result in terms of A, B's, and C's. Oops. So we have the same formula, we just rearranged it for the SSS situation, the SAS situation, right? Is everybody okay with that? Again, my suggestion for you is when you're typing this into your calculator, type it all in one line. Don't try to do some sub-simplifying because you'll end up oftentimes making an order of operations mistake that the calculator doesn't make if you just type it in exactly like it looks like on your sheet of paper. So let's go back to this problem here and fill our stuff in. So R was 10, P was 5, Q was 8. Second cosine, and then alpha y equals. Here it's going to be really important that you're using the fraction command. It makes your life way, way, way easier because you don't have to muck around with a whole mess of parentheses that you would otherwise. You can just literally type it in exactly like it looks like on your sheet of paper. If you catch an error on this, the most likely error is that you use the subtraction symbol in front of the -2 rather than a negative sign. That happens a fair bit with students. So when I do that, I get 97.90 or thereabouts. So that's my value for angle R. Now in this case, because angle R was obtuse, it doesn't really matter which angle I find next. But if angle R was acute, then it definitely matters because we don't want to run into that bad SSA situation. So as a result, I'm always going to assume it's the SSA situation, do it in that same order that I would want, which means find the smaller of the two angles next. If R is acute or is obtuse like it is here, it didn't matter. This is fine. If R was acute, though, then I would need to do this one next, or else I'm going to get the wrong answer, because I'll probably miss that there's 2 triangles necessary here and goof that up. So I'm always just going to do the smaller of the 2 angles next, which would be angle P. So that's going to be cosine inverse of P squared minus Q squared minus R squared over negative 2QR, or 10 squared minus 8 squared minus 5 squared over negative 2 times 8 times 5. And then it's just calculator time. How's this feeling so far here, students? The actual number punching should be pretty easy, right? There's no complicated algebras going on here. We're just basically plugging stuff into formulas and then typing it into our calculator. What in great googly moogly, Mr. Kulik? Okay, so P is 5 and Q is 8. That was okay. And R is 10. I think I transposed R and P there and did the exact, yeah, I did the exact same thing I did before. It's pretty dumb, Mr. Kulik. I know. You ever make a mistake? It happened to me. All right, let's just try to edit this. All right, 2969. And then, so angle Q then is just going to be 180 minus angle R minus angle P. And then we're donezo's. So 5241. Is this okay? Again, I think mostly pretty straightforward, right? We're just, again, using formulas. The tricky part is remembering like which formula to use and then the order that we have to do stuff. But the actual plugging stuff into formulas is pretty easy. In section 7.4, we're going to talk about areas of triangles. Okay, let's go back to our geometry days. Who remembers the area formula for a triangle from geometry? 1/2 base times height. Great. So in the picture I've drawn of the triangle, which side is the base? The bottom, sure. Which side is the height? Yeah, none of the sides are the height, right? The height is this altitude. And that's the catch, right? If you're not given that height, how do I go about finding it? Yuck, right? Yuck. That's a lot of work to do that. What can I do? Well, there's a couple of alternatives. So one of them is I can use this version. So when should I use this? I have to have a side, another side, and then the included angle. So what is that situation there that we've just drawn? What three-letter situation is this? Side, angle, side. Can I use this if I have like angle, side, angle, or angle, angle, side, or side, side, angle? Not quite. I'd have to do a law of sines first. Get my missing part so I can get an S or a side angle side, and then I can use that formula. That's kind of the worst case scenario for one of these area problems, is where it's not just set up as a side angle side situation. You might have to do a law of sines or something to get the next piece. Or there's another version. The other version is this area formula. We have S times S minus A times S minus B times S minus C, where S is just A plus B plus C all divided by 2. This formula has a name. It's called Heron's formula. I believe Heron was an Egyptian mathematician, but he's probably actually Greek, because I think it's post Alexander the Great, where all peoples in modern day Middle East are kind of Greek influence anyways. And this quantity S, we call this the semi-perimeter. It has a name. It doesn't really matter if you call it that or not, though. So what do we need in order to use Heron's formula? I need the side lengths, right? When should I use this? In an SSS situation. Since I'm using it in an SSS situation, what else do I have to be careful about? I have to be careful that the triangle exists. So I still have to be careful. I have to check those to make sure it's possible to do the triangle. If you forget to check, what's likely going to happen in a Heron's formula situation, other than getting the wrong answer? What kind of answer will you probably get? Might get a negative area. Like you'll get an error because you're trying to take the square root of a negative or something. It's probably what's going to happen. So you do need to be a little bit careful. All right, let's do some area examples. But these are the easiest yet of the problems we're doing. Isn't it nice when the chapter kind of gets easier as you go through it? Right? Like the law of cosine stuff was easier than law of sine stuff in general. The area stuff's even easier than that. All right. Well, again, I'm going to start by drawing a picture so I can identify the situation. Bless you. You're welcome. So what situation am I in here? Side angle side. So I'm going to use that first version. So area is going to be 1/2 BC sine A. This formula is lovely because if it's side angle side, the two sides are going for the sides. It doesn't matter which one you put in where. The angle goes in for the angle. I don't have to think about it. It's like calculator time here. Right from jump. Them's like the easiest problems in the world. So 1/2 times 10 times 27 times sine of 43 and 9207. Now here's something Mr. Kulik's going to be picky about. Notice in this problem the lengths of the triangle are given units. What should the unit be on this 9207? It's not a degrees, because what are we finding? We're looking for an area, so it should be millimeters is close, squared, yeah. So if you don't put the millimeter squared on that, I'm going to make a little deduction on there. Side lengths should have like a unit, a linear unit, like a unit to the first power, no squared. Areas should have a unit squared on them. Okay? And whatever the unit is in the problem will be the unit in your answer. So you don't have to think about it that hard, but you do need to be careful about that. Everybody feel okay on that one? Pretty easy though, right, Matt? Sure thing, homie. All right. Do one more example. So find the area for this triangle. Before I even get started, I already know which situation this is. I don't have to draw a picture. How can I tell just from reading the problem what situation this is? Side, side, side. I'm given three lengths. I know it's got to be side, side, side. I got to check before I start if this problem is possible. How do I check that again? Yeah, the sum of the legs have to be greater than hypotenuse. Which are the two leg measurements? 5 and 8. And that has to be greater than 10, which it is. So I'm good. Notice I didn't even bother figuring out what 5 plus 8 is. I really don't care. I just know it's bigger than 10. I'm happy with that. So I'm going to be using Heron's formula. So I'll start by computing S, which is A plus B plus C divided by 2. So that's 23 over 2, or 11.5. And I'll just plug that into Heron's formula now. What's 11.5 minus 5? 6.5. What's 11.5 minus 8? Or 3.5? And 11.5 minus 10? 1.5. Now you could just type it all into your calculator, but I'm just going to save myself some button pushing and just do it this way. But you could type it all in, plugged into the formula if you wanted to. So I get 1981. And what should the unit be on this? Meters squared. These area ones are pretty nice, right? Real easy. How would I get the 11.5? 23 divided by 2. No. S is the semi-perimeter. It's A plus B plus C divided by 2. Semi meaning half. So half the perimeter is A plus B plus C divided by 2. You know what we just did, guys? We just finished chapter 7. What? That was like the fastest thing ever. I think, so I had the same class last period. My plan initially was to do the chapter 7 test on Friday. It sounds like there's already some test conflicts on Friday. So we'll just push it to the next class day. We'll just start chapter 8 in the meantime. Hope nobody's too upset by that. Given that we just finished chapter 7, what haven't we done that we do once per chapter? Homework quiz. What would I expect for next class? Homework quiz. What should you be able to do? Law of sine and cosine problems. I would say be a good place to start. Everybody cool with that? Okay. I'm going to stop here. We got 20 minutes or so left in class. My suggestion to you, get your stuff out and start on the homework set. 1 through 30 is going to be due on Sunday. If you haven't started that, I'd get a start on it. Maybe start with the area problems. If you're just like, 20 minutes isn't enough to really get into anything, you can probably bang out those area problems in 20 minutes without a problem. If you're looking for something short that you can do in 20 minutes, I think that part you for sure can do. The last 10 or so were area problems, I think. 6, 8, 10, I don't remember.